Namaste students. Nowadays we are dealing with the nitrogen family, and in nitrogen family we have an important element that is known as phosphorus. So today in this video we will learn about the two important chlorides of phosphorus and the two important oxides of phosphorus. So without any delay, let's get started. Students, in our previous videos, we have studied that the nitrogen family forms two types of halides, that is trihalides and pentahalides. So phosphorus also belongs to the same family. So phosphorus also forms two types of halides, and in this we are specially talking about the chlorides. So phosphorus forms two types of chloride, that is phosphorus trichloride and phosphorus pentachloride. So first of all, we will take phosphorus trichloride. First, we will take phosphorus trichloride. Now, the formula of the phosphorus trichloride, you all know, that is PCl3. Yes, that is PCl3. So the formula of phosphorus trichloride is PCl3. Now, first of all, if I talk about the preparation of phosphorus trichloride, we can prepare phosphorus trichloride by two methods. We can prepare phosphorus trichloride by two methods. First method is by the action of the thionyl chloride on the white phosphorus. What is our first method? By the action of thionyl chloride. What is thionyl chloride? Thionyl chloride is SOCl2. SOCl2 is known as thionyl chloride. Thionyl chloride, THIONYL, thionyl chloride. So by the action of thionyl chloride on the white phosphorus, we can prepare phosphorus trichloride. Reaction P4 plus SOCl2, then it gives, what is P4? P4 is the white phosphorus, SOCl2 is thionyl chloride, then it gives PCl3 plus SO2, PCl3 plus SO2 plus S2Cl2. Now balance the reaction by your own. So S2Cl2, PCl3 you know, that is phosphorus trichloride, SO2 is sulfur dioxide, S2Cl2 is sulfur monochloride. It is sulfur monochloride which is present in dimer form. So by the action of the thionyl chloride on the white phosphorus, we can prepare PCl3. Next we will talk about the laboratory method. In laboratory we can prepare PCl3 by heating white phosphorus in a current of dry chlorine. There should be a perfect dryness. There should be no moisture. So in lab we can prepare PCl3 by heating white phosphorus in a current of dry chlorine. By heating white phosphorus in a current of dry chlorine. So the reaction become, what will be the reaction? The reaction become P4 plus Cl2 on heating gives PCl3. Here it becomes 4 and here it becomes 6. This you have to balance. So we can prepare phosphorus trichloride by any of the two methods. This one is the laboratory method and this one is our another method. Now next, if I talk about the structure. Now the hybridization of PCl3 is sp3, means phosphorus in PCl3 is sp3 hybridized and form 3 bond pair with the chlorine, whereas 1 lone pair, so the shape becomes pyramidal. So the hybridization is sp3, but the shape is not tetrahedral because of the presence of 1 lone pair, and because of the presence of the lone pair, the shape becomes pyramidal. Now, if I talk about the next, that is the physical property. Next, we will deal with the physical properties of phosphorus trichloride. Now, the first physical property of trichloride is it is colorless, pungent liquid. It is a colorless liquid with a pungent smell. So, its first property is colorless liquid. Its state is liquid, so it is colorless liquid with a pungent smell. With a pungent smell. And the second property, the second physical property of PCl3 is it fumes in moist air. It fumes in moist air. Why it fumes in moist air? Due to the formation of P4O10. Why it forms in moist air? Due to the formation of the P4O10. So, preparation, structure and physical properties. Now, we will deal with the chemical properties of PCl3. Now, we will talk about the chemical properties of PCl3. Now, first, if I talk about the reaction with the water. So, PCl3 reacts violently with the water, means the reaction is very fast, and this PCl3 when reacts with water, it forms H3PO3. It forms H3PO3. So, first is the reaction with the water, which is a very violent reaction, very fast reaction. So, when PCl3 reacts with water, then it forms H3PO3 plus HCl. This is phosphorus acid. H3PO4 is phosphoric acid and H3PO3 is phosphorus acid. So the reaction is very violent. The reaction is very violent, means very fast. So PCl3 reacts violently with the water to form H3PO3. Next, when it reacts with sulfuric acid, then it forms chlorosulfonic acid. How we can show the reaction? I'll split for formation of product. I'll split H2SO4 like this. HOSO2OH. So finally it becomes H2SO4 plus PCl3. So what you have to do, you have to remove this OH, you have to substitute this OH by Cl, so it becomes HOSO2Cl. So it becomes chlorosulfonic acid. And the byproducts are HCl plus HPO3. Now what is HPO3 here? It is metaphosphoric acid. H3PO3 is phosphorus acid and HPO3 is metaphosphoric acid and SO2. So when PCl, main product is this one, these are the byproducts only. So when PCl3 reacts with the sulfuric acid, then it forms chlorosulfonic acid. Now next, third, PCl3 reacts with chlorine, PCl3 reacts with oxygen and PCl3 also reacts with sulfur. So when PCl3 reacts with chlorine, then it forms PCl5. When PCl3 reacts with oxygen, then it forms POCl3. Now what is POCl3 here? POCl3 is phosphorus oxychloride. This is POCl3. And when this PCl3 reacts with sulfur, then it forms PSCl3. And this is known as phosphorus thiochloride. So it reacts with chlorine, it reacts with oxygen and it reacts with sulfur. When it reacts with chlorine, it forms PCl3. When it reacts with oxygen, it forms phosphorus oxychloride. And when it reacts with sulfur, then it forms phosphorus trichloride. So first reaction with the water, which is a violent reaction. Second reaction is the reaction with sulfuric acid to form chlorosulfonic acid. Third reaction is with Cl2O2 and acid, and it forms PCl5, POCl3 and PSCl3. Now fourth one is the reaction with the Grignard reagent. Reaction with the Grignard reagent. So when it reacts with the Grignard reagent, it substitute the other other part of the Grignard reagent except the alkyl group, means it replaces the alkyl group or aryl group from the Grignard reagent. For example, when PCl3 reacts with CH3MgCl, so here the R group is CH3, so this reacts with phosphorus. So our product becomes PCH3 whole thrice, that is trimethyl phosphine. It forms the substituted product of the phosphine. So it is trimethyl phosphine, and with trimethyl phosphine we get MgCl2. Now suppose in the place of this we have C6H5, that is aryl group. First we have alkyl group and now we have aryl group. Then it forms C6H5 whole thrice plus MgCl2. And here this one is known as triphenyl phosphine. This one is known as triphenyl phosphine. So when it reacts, means when phosphorus trichloride reacts with the Grignard reagent, it forms the substituted product of the phosphine, whether it is alkyl trialkyl phosphine or it is triaryl phosphine. Now fifth one, it also reacts with the finely divided metal but on heating. So it reacts with the finely divided metal, but it reacts with the finely divided metal on heating, and the product which is obtained, it depends upon the nature of the metal with which it is reacting. Now suppose P4 is reacting with silver, which is a less reactive metal. Then here, sorry, not P4, it's PCl3. PCl3 reacts with silver, and silver is a less reactive metal. So it forms AgCl plus P4. It forms AgCl plus P4, but when this PCl3 on heating reacts with sodium, then it first forms NaCl, but along with NaCl, it will not form P4, it will form Na3P. Na3P, that is sodium phosphate. So when PCl3 reacts with metal, yes, PCl3 reacts with metal, but with the finely divided metals and on heating. So it reacts with finely divided metals on heating. Next property is it is used as a reducing agent. From the reaction we get to know that how it is used as a reducing agent. Used as a reducing agent. Now what happened? Suppose PCl3 when reacts with SO3, then it forms POCl3 plus SO2. So here it takes oxygen from this, so it will reduce SO3 into SO2, so therefore it acts as a reducing agent. Similarly, when PCl3 reacts with SO2Cl2, then it forms PCl5 plus SO2. Then it forms PCl5 plus SO2. Here, if I calculate the oxidation state of sulfur, then it becomes X minus 4 minus 2 equals to 0. So X minus 6 equals to 0. So X equals to plus 6, and here X equals to plus 4. So sulfur get reduced, and because sulfur get reduced, therefore the PCl3 acts as a reducing agent. Similarly, when PCl3 reacts with SOCl2, when PCl3 reacts with SOCl2, then it forms POCl3 plus PCl5 plus PSCl3. Then it forms POCl3, PCl5 and PSCl3. Similarly, when PCl3 reacts with S2Cl2, that is sulfur monochloride, then it forms PCl5 and PSCl3. So from these reactions, we get to know that PCl3 is used as a good reducing agent. PCl3 is used to replace the hydroxyl group. PCl3 is used as a substituent for replacing the hydroxyl group. So next property is it reacts with the compounds which contain hydroxyl group. It reacts with the compounds which contain hydroxyl group. Compounds containing hydroxyl group. Hydroxyl group. So suppose if I take the first compound, that is the ethanol. That is CH3CH2OH. When this reacts with PCl3, then it forms CH3CH2Cl plus H3PO3. So OH is replaced by Cl. So it is used to replace the OH group from the hydroxyl group containing compound. That's why it reacts with the compounds containing hydroxyl group. Similarly, suppose if I take CH3COOH, it also contains hydroxyl group. When it reacts with PCl3, then it forms CH3COCl plus H3PO3. And suppose I have CH3CONH2, then when it reacts with PCl3, what happened? No, sorry, not this one, because this doesn't contain hydroxyl group. First one CH3CH2OH, second one is CH3COH. Now suppose third one is C6H5SO3OH. SO2OH. Suppose C6H5SO2OH plus PCl3, then it forms C6H5SO2Cl plus H3PO3. So in this way, it is used as a substituent group for replacing the hydroxyl group from the compound containing hydrogen. So these are the chemical properties of phosphorus trichloride. So here phosphorus trichloride is done. Now we'll talk about phosphorus pentachloride. Phosphorus pentachloride, the formula of phosphorus pentachloride is, what is the formula of phosphorus pentachloride? Yes, it is PCl5. It is PCl5. So first of all, we will talk about the preparation of phosphorus pentachloride. So phosphorus pentachloride can be prepared by the two methods. Just like that of the phosphorus trichloride, we can prepare phosphorus pentachloride by the two methods. Now what are those two methods? First of all, by the action of the sulfuryl chloride. First of all, by the action of the sulfuryl chloride. Action of sulfuryl chloride, that is SO2Cl2. By the action of the sulfuryl chloride on white phosphorus, we can prepare PCl5. P4 plus SO2Cl2, then it gives PCl5. So when P4 reacts with SO2Cl2, means sulfuryl chloride, it is sulfuryl chloride. So when white phosphorus reacts with sulfuryl chloride, then it gives PCl5, and when white phosphorus reacts with sulfonyl chloride, it forms PCl3. And next method is by heating white phosphorus with an excess current of dry chlorine. Means if we take limited amount of chlorine, means a sufficient amount of chlorine, then it forms PCl3. But if we take excess amount of the dry chlorine, then it forms PCl5. So P4 when reacts with Cl2, here Cl2 is excess, then it forms PCl5. So there are two methods through which we can prepare Phosphorus Pentachloride, first one by the action of the sulfuric chloride on white phosphorus, and second one by heating white phosphorus in with an excess current of dry chlorine. Next, if I talk about the structure, in PCl3 we have studied that hybridization is sp3 and the structure is pyramidal. In this, the hybridization is sp3d and the structure is trigonal bipyramidal. Triangular bipyramidal or trigonal bipyramidal. So the structure is trigonal bipyramidal as well as geometry is also trigonal bipyramidal, because in this we don't have any lone pair, we have only bond pair. But in PCl3 we have 3 bond pair and 1 lone pair, therefore the geometry is tetrahedral but the shape is pyramidal. In this, the geometry is also trigonal bipyramidal and the shape is also the same due to the absence of lone pair. Next, we'll talk about the physical properties. If we remember PCl3 is a colorless liquid, but it is a pale yellow crystalline solid. It is a pale yellow crystalline solid with a pungent smell. Both have pungent smell, but PCl3 is present in liquid form, whereas PCl5 is present in the solid form. So pale yellow crystalline solid with pungent smell. And the second property is in the solid state. In the solid state, it doesn't present in the form of PCl5. It present in the form of, in solid state, it present in the form of PCl4 positive, PCl6 negative. So it will not present in the form of PCl5 in the solid state. In the vapor state, it is present as a covalent PCl5, but in the solid state, it is present as a crystalline solid of molecule PCl4 positive and PCl6 negative. So these are the physical properties of phosphorus pentachloride. Now we'll study the chemical properties. We will study the chemical properties. First of all, dissociation. On heating, it dissociates to give PCl3 and Cl2. On thermal decomposition, first of all, decomposition or dissociation. On heating, it undergoes thermal decomposition to form PCl3 and Cl2, and therefore it is used as a good chlorinating agent. Why it is used as a good chlorinating agent? Because on heating it decomposes to give PCl3 and Cl2. Now next property is it reacts with water, but the reaction occur in 2 steps. Though it reacts with water like PCl3, but the reaction occur in 2 steps. So for second, reaction with the water. So when PCl5 reacts with water, first of all it will form POCl3. And when this POCl3 reacts with water, then it forms H3PO4 plus HCl. So though it reacts with water, but the reaction is not as much fast as compared to PCl3. Means PCl3 reacts violently with the water, but PCl5 doesn't react that much fast, and it reacts in a 2 step. First, it reacts with the water to form phosphorus oxychloride, and then phosphorus oxychloride reacts with the water to form the phosphoric acid. In that we get the phosphorus acid, in this we get the phosphoric acid. Next, it also reacts with the compound containing hydroxyl group, just like of PCl3, but the byproducts are different. It also reacts with the compound which contain hydroxyl group, just like that of the PCl3, but the byproducts are different. For example, CH3, CH2, OH. it reacts with PCl5. Then what happened? It formed CH3, CH2, Cl. The main product is same. The main product is same, but the byproducts are POCl3 plus HCl. POCl3 plus HCl. POCl3 plus HCl. Similarly, CH3COOH. When this reacts with PCl5, the main product is same, that is CH3CO, Cl, plus the byproducts are POCl3 plus HCl. So we get different byproducts when we take PCl3 or PCl5, but the main products are same, that is the substituted product in which OH is replaced by the chlorine. Next, it reacts with fourth one when PCl5 reacts with when PCl5 reacts with P4O10. Suppose when PCl5 reacts with P4O10, then it forms POCl3, then it forms POCl3, and when PCl5 reacts with S4O10, then it forms PSCl3. Means when it reacts with P4O10, phosphorus pentachloride, then it pentaoxide, then it forms phosphorus oxychloride, and when it reacts with S4O10, then it forms phosphorus thiochloride. So it reacts with P4O10, it reacts with S4O10, and in both the case it forms oxychloride and thiochloride. Next, if we talk about the reaction of PCl5 with the chloride ion acceptor, reaction with PCl5 with that compound which can accept chlorine, like PCl5 reacts with BCl3, because BCl3 is an electron deficient, so it can easily accept the chloride ion. When it reacts with, so it forms PCl4 positive, BCl4 negative. It accepts an chloride ion from PCl5, so PCl5 becomes PCl4 positive and it becomes BCl4 negative. Similarly, PCl5 reacts with niobium tetrachloride to form PCl4 positive and niobium pentachloride negative. So it reacts with the compounds which have the tendency to accept chloride ion. But PCl5 don't have this property. PCl3 don't have this property. PCl5 have this property, that PCl5 reacts with the chlorine accepting compounds to form the product. Now when it reacts with KF, next reaction of PCl5 with KF, then it forms what it forms? K positive, PF6 negative plus KCl. So it forms an ionic compound, it forms a complex compound, that is K positive, PF6 negative and KCl. Next, when it undergoes reduction, means PCl5 plus H2. When it undergoes reduction, then can you imagine what will be our product when it undergoes reduction? Then our product is, one is obviously HCl and another one is PCl3. So PCl3 plus HCl. So these are the chemical properties of PCl5. It undergoes thermal decomposition to form PCl3 and Cl2 and hence used as a good chlorinating agent. It reacts with the water but not as much violently as PCl3. It reacts with the compounds containing hydroxyl group and make a substituted product. It reacts with P4O10 and S4O10 and it reacts with the chloride ion acceptor. It reacts with KF and it undergoes reduction to form PCl3 and H2O. So this is all about PCl5. Now we'll study the oxides of phosphorus. What we'll study? The oxides of the phosphorus, because the chlorides are done. Phosphorus trichloride as well as the phosphorus pentachloride. In both we have studied the preparation, we have studied the structure, we have studied the physical properties and we have also studied the chemical properties. Now we'll study the oxides of phosphorus. Now phosphorus forms two types of oxides, P4O6 and P4O10. So first of all, if I talk about P4O6, so P4O6 can be prepared by heating. P4O6 can be prepared by heating white phosphorus in a limited supply of air. By heating white phosphorus in a limited supply of air, we get P4O6, and by heating white phosphorus in excess supply of air, we get P4O10. So P4O6 preparation is by heating white phosphorus in limited supply of air. In limited supply of air. So it becomes P4 plus O2. Here O2 is limited. On heating, we get P4O6. But if we talk about P4O10, P4O10 is prepared by heating white phosphorus in excess supply of air. In excess supply of air. P4 plus O2 excess. Here when it reacts with excess of O2 on heating, then it forms P4O10. So this is all about the preparation of P4O6 and P4O10. Simple method, we have to heat the white phosphorus in the presence of the oxygen. If it is in limited amount, then it forms P4O6, and if it is in excess amount, then it forms P4O10. Next is when it reacts with the water. So both are acidic in nature. P4O10, both the oxides are acidic in nature, because when both reacts with the water, they form acid. So P4O6, when P4O6 reacts with the water, then it forms H3PO3, and when P4O10 reacts with the water, then the product depends upon the temperature of the water. If the water is cold, means if the temperature is less, then it forms HPO3, that is metaphosphoric acid. And when it reacts with the hot water, then it forms H3PO4. So both are acidic in nature. Why both are acidic in nature? Because when both reacts with water, they form acid. This form H3PO3 and P4O10 form two compounds, and that two compounds depend upon the temperature of the water. If the temperature of the water is cold, then it forms HPO3, and if the temperature of the water is hot, then it forms H3PO4. Next, if we talk about because the affinity of P4O10 is more with the water. If we compare P4O6 and P4O10, the affinity towards the water is more of P4O6. So P4O6 used as a good dehydrating agent. For example, I have to dehydrate HNO3. Suppose if I have to dehydrate HNO3, I use P4O10. Now I have to remove water from this. So it should be 2, because in one HNO3 I have only one hydrogen. So it should be 2. So 2 HNO3 plus P4O10, it gives what it gives. After removing H2O, what remain here in this? N2O5. Because what it becomes? H2N2O6, and I have to remove water. After the removal of water, it becomes N2O5. And along with this, either we will get HPO3 or H3PO4. Now these two products depend upon the temperature of the water. If the water is normal, then we get HPO3. If the temperature of the water is high, then we get H3PO4. Because of these two reactions, you get to know. Similarly, suppose if I have to dehydrate H2SO4. So I'll react H2SO4 with P4O10. Then it forms, it remains SO2 plus either HPO3 or H3PO4. So only these things we have to study about the oxides of phosphorus. The main thing we have studied in this video are the properties of phosphorus trichloride and phosphorus pentachloride. So students, that's all for today. I'll see you in my next video with a new topic of the nitrogen family. Till then, take care.